for 18, number 1. 5 times the difference of a number and 3 is 17. Who wants to tell me what they got for that one? Javier, let's just do the next one, okay? Who were you raising again? Okay,
Okay. I got 5n minus 3 equals 17.
You could have made that a different variable, but 5 times some variable minus 3 is 17. Hold on. I'm going to rearrange this a little bit. Because we're multiplying 5 times the difference of, this needs to be in parentheses. We need to find the range of this. So lowest to highest, what was the range of this? Say it again. All round numbers. So in your set lower notation, that would be your y ER. In your interval notation, what would all real numbers be? From negative infinity to positive, yes. If it's all real numbers, it's going to start at negative infinity and go to positive infinity. It's going to be everything. Okay. Number 3 I'm going to show because I think this became more complex than I really wanted it to. Yeah. So I'm going to talk through these methods and then show you how you would do it if you were just graphing, which you could have done. So if you use substitution, it did not matter which one you chose, but you would have needed to solve one of these equations for one of the variables. I solved mine for x in the second one. So we would add 2y to both sides to get x equals 2y plus 5. This is not how you needed to do it. This is just one way. Take this, put it back into the other equation, distribute, combine like terms, and then solve for y. Here I got 9 over 7. Put that back in, and you got 17 over 7. I think one of those was negative. This was negative 9 sevenths. That's why there's 3. Elimination, you would need to get one of the coefficients to be the same. It doesn't matter which. I made my y values the same, so I multiplied the first one by 2. Added these together to get 7x equals 17. And solve for x. And then put that back in to solve for y. Graphing. Someone read off those equations for me. 3x plus 1 equals 6. And x minus 2y equals 5. If we graph them, the intersection point would be a bunch of decimals. You would really need to know what those decimals are. So going back to the numbers I found, what were they? 17 over 7 and 9 over 7. Negative 9 over 7. That would be the same decimal, and 17 over 7. That would also be the same decimal. But if you were to get decimals and you didn't know what those fractions were, leaving them as decimals was fine. So yes, that was more complex than I really wanted it to be because I wanted them to be whole numbers, but that didn't work out that way. Questions on that one? Number 4, how would we solve this for y? How are you going?
You do plus 5x So we write it so it's negative y equals positive 5x plus 1. Then we divide negative 1, and add it to divide by both. So you get y equals negative 5x minus 1.
Right? And then the last one, we needed to solve this equation. So distribute, we have negative 5x plus 15 minus 2x equals 46 minus 4x minus 4. Combine your like terms. We have negative 5x and negative 2x that we can combine. We have 46 and negative 4 on this side that we can combine. Then we have different things to move. What do we want to move? Subtract 15, okay. Negative 7x equals 27 minus 4x. Then we would need to add 4x to the other side to get negative 3x and divide both sides by negative 3. X equals negative 9 would have been your final answer. Do we have any questions on today's show print? Get your notes out in front of you and find this page. So last class we talked about how to simplify square roots and cube roots when they were just numbers. Now we're going to add variables to that mix. So just taking those things and bumping the difficulty level up a notch. So what we did last class will still apply because there will still be numbers there, as well as variables. So there are, I'm going to show you 2 different ways to go about doing this, and you do whichever you feel more comfortable with, just like last class. I don't really remember what this says. Okay. So if m is a multiple of 2, that means it can be divided by 2. We're going to use the rule, and this is just one way. The square root of a to the m equals a to the m divided by 2. Looking at that, hearing that, writing that probably doesn't make any sense, but when you do it, hopefully it will. M is not a multiple of 2. We're going to break it apart. So the square root of a times, or a to the m, will equal the square root of a to the m minus 1. We're going to subtract 1. And then have an a by itself. Again, in reality, that does not make a whole lot of sense, but we're going to do this. So starting with the first one, we're going to do this both ways. Right? Using this rule, if this is a2, and I'm actually might show you a third way as well. Using this rule, if this is a multiple of 2, which it is, I can divide this by 2. So 2 divided by 2 is 1, which means left would be x to the first power. So what I did was take this 2 and divide it by 2 to get x equals 1. Anything to the first power is really just whatever it is. So like all of these numbers up here really have an exponent of 1. We do not see it. So we could just write this as x. We don't have to include the 1. So that's one way we could do that. Another way we could do that is we could think about how many x's is x squared. I know that sounds like I'm asking a harder question than I really am, but 2. So let's say I wrote that out. X squared equals x times x, right?
With yes. What's the one for n?
I think it was A to B. Wow.
How does that work?
Which part? This. So if it's a multiple of 2, divide it by 2 and see what's left. So if you like that method, we'll keep using that. You can keep using that. You could do it this way, where you write out however many this is. I would maybe not advise this for bigger exponents, but it would still work. You would just have a lot, maybe need more space. So if we have 2 x's, think about our square roots when we were factoring and we were looking for pairs. If we have a pair of x's, those get to come out, and there would be nothing left on the inside. The other way, I personally like this way of the 3, is if I'm looking at this, imagine there's a 2 on the outside. I mean, there is one is invisible 2, that index is 2. Whatever the exponent is, think about it like this. 2 goes into 2 how many times? 1. And there would be nothing left over. So that would be just 1 with nothing on the inside.
So the ant is just x.
Yes. So whichever way makes more sense, use that. We'll do them all again with something that would have a bit more work. Before we do number 2, what questions do we have on that, Avina? If it's not, then you'll have multiple things. We'll do that. Okay. For number 2, you have a 9. Square root of 9 is what? 3. We know that much. If it's a perfect square, that all of those rules still apply for the numbers. Let's just focus on the variables. We're going to break this down to the 3 rules. I should have did this in a different order. Okay. For the first one, this is a multiple of 2. I could divide that by 2, and I would get 5. So that means this would be k to the 5th. If I'm doing it the second method, k to the 10th would be 10 k's. I'm going to draw that out real fast. 3, 4, 5, 6, 7, 10. This is why I said doing this with bigger exponents, you may not want to do this because you'll fill up your page real fast. But if we're looking for pairs, we have 1, 2, 3, 4, 5 pairs with nothing left over. So that would still give you your k to the 5th, and you would still have needed to simplify that part. I could have also wrote 9 times, or 3 times 3 equals 9. And that would have meant the pair that comes out. For the last one, if there's an invisible 2 out here, 10 goes into 2, 2 goes into 10 how many times? 5. With that one, there's less work to really show. You have to just do it. All of these had nothing left over, so let's do one with something left over so you would see how that works with each rule. For number 3, This is not divisible by 2, but 4 is divisible by 2. So we're going to break this into n to the 4th and n. And then we can divide 4 by 2 and get 2. And the one that was by itself would stay on the inside. So that's what that square root of a to the m minus 1 times m was. Whatever this number, so this is just for the first way. Whatever this number is, subtract 1, so 4. Split that into 2 parts. So you have n to the 4th, and then the one you subtracted, move it right next to it. Divide the 4 by 2, and the one you did not divide, leave it stays in the wrap. That's one way. The second way, n to the 5th would be 5 n's. How many pairs would we have?
2.
With 1 left over, that would be n times n, with n inside. N times n is n squared. Then the last method, 2 goes into 5 how many times? Twice. With how many left over? So whichever way makes the most sense to you, that's what I want you to do. If you're like, that first way does not make sense to me at all, I'm not going to do that at all, don't worry about it. If you really like the expanding method, go with that. Or the last one. Do we have any questions on any of those 3 methods so far? There are 3 more we're going to do. So for number 4, we have 40 and a to the 19th. So you could do the square root of 40 one way. So let's say you do that the shorter way that we talked about last class. And then you do the a to the 19th the expanded way, the one in dark purple. Or vice versa. It does not matter as long as you get both. So I'll let you guys choose for each one. For the square root of 40, do we want to do that the short or the longer way? Short is what I heard, so we'll do that. Okay. So you may need to look back at your perfect squares. What is the highest perfect square we can divide 40 by? I heard 16, and I heard something else. 8.
Divide 40.
Divided by 40, yeah. Would 16 work? No. It would be 8.
8, yeah.
Oh.
8's not a perfect square. 4 is. So 4 and 10. Square root of 4 is what? 2. To make sure that you cannot break down 10 or simplify it anymore, give me factors of 10.
5 and 2.
5 and 2. Are those prime numbers?
Yes.
Yes. So it's completely factored and neither of them are the same. So square root of 10 is going to stay square root of 10. Now we have a to the 19th. Let's do both. First method for the variables, second method for the variables, third method for the variables. That's the one I saw most yeah. So 2 goes into 19 how many times? There's 9. So that would be a to the 9th. How many would be left over? 1. So we have all these different things that we need to multiply together. Anything that is not underneath the square root is going to come out from. We have 2 a to the 9th. I'm trying to make one actually look like an a. Underneath, we would have the square root of 10 and a. So our final answer would be 2a to the 9th times the square root of 10a inside. These get harder to check because there's no way to really check the variables. We can still check the number, but we can't check the variables. So I can say the square root of 40 and 2 times the square root of 10. And I know that part is right, but there's no way for me to really know about the variables. That's where it gets a little tricky, because you have to have done it right. What questions do we have on 4 before we continue? Carry on. A, 9, A. Having those together is probably not the best idea. Keep that in mind if you have A's and 9's together on the test. That way I know, make sure I know which one is which. All right, let's do number 5. 25, is that a perfect square? Yes. So that's going to be 5. No need to simplify that more. 6 can be divided by 2. So that would be 3, x to the 3rd. And then, if we're using the last method, 2 goes into 13 how many times? 6 times. 6 times, so x, y, not x. Y to the 6, with how many left over? 1. So when you have multiple variables, put it in alphabetic order, or try to. So 5, x to the 3rd, y to the 6, times the square root of y. So for this one, there's no real way to check this except for to do the square root of 25, which we know is 5. So I know that's discouraging. What questions do we have on this one? We're going to do one more together, and then I'm going to let you try some on your own. There's a lot, but we're going to break it down step by step. So number 12. We have a number on the outside. Let's go ahead and bring that down first. Square root of 144, is that a perfect square?
Yes.
Yes. 12. 16 can be divided by 2. 10 can also be divided by 2. So y to the 5th. And then 2 goes into 7 how many times? 3. Z to the 3rd with how many left over? 1. So the last thing we need to do is multiply -5 and 12. -60. So -60, x to the 8th, y to the 5th, z to the 3rd times the square root of z. Oh yeah, that's fun. Sometimes. Sometimes. Yeah. All of the above. All of those comments, yes.
Square root of z.
I want you to try these 6 through 10. I'm sorry, 6 through 11. I'll give you 10 or so minutes to work through those, and then we'll come back and we'll talk about them. Questions on these? Also let me know. Alright, so starting with number 6. Final answer should be p to the 7th, q to the 4th, times the square root of PQR. Here is only once. Okay, students. Are you going to sit at the chair for a bit? To answer your question, this only has an exponent of 1. So if we're thinking of all of our different rules, we can divide 1 by 2. 2 doesn't go into 1 evenly. So because of all of those things, R would stay on the inside. Yeah, so if it doesn't have an exponent, it's assumed to be 1, and it would stay on the inside. Yes. Number 7. Final answer is 3b times the square root of 7. Can you see from here? Questions on 7? Number 8. 3n times the square root of 3n. Questions on 8? Number 9. Final answer was 64 times y squared times the square root of 5x. Questions on that one? Final answer was -12u times the square root of 5v. Questions on that one? And 11, 8p squared times qr to the 9th times the square root of 2p. Say that one more time. Where we break it down. Or 320. Yeah. So give me 2 factors of 320 besides 64. Have your factors.
8.
And then yours would also work. What did you say? 20. I believe that was work. Okay. Whatever the numbers are, it doesn't matter. This is a big number, so you're going to have a lot of factors. Factors of 8 would be 2 and 4. Give me 2 factors of 40. 1 and 4. 10 and 4. And then we can break down the 4s to be 2 and 2, and 2 and 2. Factors of 10. 5 and 2. Right, so we have one pair of 2s, another pair of 2s, another pair of 2s. So we have 2 times 2 times 2. There was already an 8 at the beginning, which is why we got 64. This would be 8. 8 times 8 is 64.
What happened to the 64 y over with the 2? So did you just like
So I'm no longer doing it this way, breaking down the 64 and the 5. I only use this if we were doing it this way. But the variables, the x would stay inside because it has the exponent of 1. So I can say times square root of x. 2 goes into 4 twice, so that would be times y squared. And then I would rearrange and simplify. So this would give me 64. This would give me y squared. And then, oh, I forgot about that. Oh, I did forget about the 5 too. So this should have been times the square root of 5. When you break it down like this, make sure you don't lose any of your stuff. It's very easy to lose a lot of your stuff because you have so many numbers, especially with big numbers. Do we have any other questions on these?
This is the notes.
Well, I'll give you that in 1 second, yeah. On the next page. So, same thing, but now it's cube roots. Here. I'm going to put your cell phone in the calculator pocket for me.
Sure.
So it's going to go in number 22. And you can grab that calculator. Okay, so same rules. This is going to be a to the m over 3. So we could do the same methods. So we'll do kind of each one. For 13, if we have the cube root of x to the third, so I'll do this all 3 ways, and then if we again don't like that first method, that's fine. 3 is a multiple of 3. So we can divide this by 3. And what would that give us? 1. Because it is a cube root, we can think about it as breaking it down. And we need groups of 3s. X to the third would be x times x times x. That would give you a group of 3 that would get to come out. Or, if you're doing it the last method, there literally is a 3 on the outside. 3 goes into 3 how many times?
3?
Once. So just like our square roots, our cube roots would be the same. Let's do another. For 14, is 64 a perfect cube?
No.
No, 4.
Yes, it's 4. So 64 is weird because of the perfect square and a perfect cube, and I think that's the only number that is both. And I'm going to do the variables, all three methods. You pick which one you like best. 9 is a multiple of 3, so I could divide that by 3 and get what? 3. So that would be m to the third. M to the ninth would be 9 sets of m's. I'm going to draw that really fast. We would need to find groups of 3s. That would be 1, 2, 3. And also 64 would be 3 groups of 4s. So we would have everything get to come out 4m to the third. If we're doing the last method, we already know the cube root of 64 is 4. 3 goes into 9. How many times? 3. Now let's jump into something that won't give me nothing left over. Number 16. Is 40 a perfect cube? No. So we're going to need to break that down. Let's use the shortest method for that. What is the highest perfect cube? We can divide that by. 4 is not a perfect cube. 8.
Cube.
So 8 and 5. The cube root of 8 is what? 2. We have this negative 3, so I'm going to bring that down. And then the cube root of 5 would stay the same. And then you could do any of the 3 methods here. 16 is not divisible by 3, but you would need to find a number that is. The closest one would be 15. So I'm going to do this, all 3 methods, and you choose which one you like the best. So w to the 15, 3 goes into that. You'd have to find the closest number that you can divide by 3. If I divide this by 3, that would give me w to the 5th with 1 w left over. If you're expanding it, you would have 16 w's. I'm not going to do that method because I don't have space. And you would need to find how many groups of 3 you could do. And it would end up being 5. 3 goes into 16 how many times? 5. With 1 left over, and that would stay inside the cube root. So our last thing is to simplify. I'm going to rearrange this. We have negative 3 times 2 times w to the 5th, all on the outside of the cube root. And the cube root of 5w on the inside. What would our final answer be? Go ahead. So because you have so many things, you may want to use parentheses to separate. So negative 6w to the 5th times the cube root of 5w. Can you see from here? Or is it difficult to see? Do you want to try sitting over there instead? Sit in the front. Sorry, I'm pointing. Sit in the front, right across. And see if that's better. If that's not, then I may move some seats around. Do we have any questions on that one? Let's do a few more. Number 18. We have the 2. We're going to bring out this negative so that way we don't have to worry about it until later. Let me know if that's better for us. We're going to bring out this negative. And then let's do 250 the shorter method. What is the highest perfect cube we can divide 250 by? What is the highest perfect cube we can divide 250 by? 125. It's okay if those don't come to you quickly and you have to look back. Or you have to do it in your calculator, either or. So 125 and 2. Say that one more time. So not 2 cubed, but when I divide 250 by 125, I get 2. Three goes into 3 how many times? Once, so that would be 1a. 3 goes into 4 how many times? 1. So that would be 1b with how many left over? 1. So there would be 1b on the inside. Now let's rearrange and start to simplify. So we have 2 times negative 1 times a times b on the outs. I'm sorry, I didn't simplify this part. Let me go back and do that real fast. The cube root of 125 is 5, and I forgot that part. We have 2 times negative 1 times 5 times a times b, all on the outside. And on the inside, we have the cube root of 2 and the cube root of b. I'll write it like this for now. Let's do this piece by piece. On the outside, what is our simplified answer? Negative 10 AB. On the inside, what is our simplified answer? It would be 2b, and we have the cube root. So the cube root of 2b. The cube actually went with the root, not the b. So use parentheses to tell that difference. What questions do we have on that? Auburn.
When we divide exponent 1 times 2 and get 2.
You would divide it by 3 now that it's a cube root.
Oh.
So if it was a square root, then yes. Right, 2 more, and then I'll let you try some. Cube roots get tricky really fast because there's so many things going on. Take it one thing at a time. Is 128 a perfect cube? No. So we need to find what is the highest perfect cube we can divide 128 by. 64. We have the cube root of 64, the cube root of 2. The cube root of 64 is what? 4. Three goes into 9 how many times? 3. So it'd be a to the third. And 3 goes into 21 how many times? 7. So we have a little bit more simplified answer because not everything was underneath the cube root. So bringing everything that's outside, we have 3 times 4 times a to the third times b to the 7th. And then we have our cube root of 2. What would our simplified answer be? Well, a to the third, b to the 7th times the cube root of 2. Takes practice, but with practice you get a little bit better at it. Let's do one more. 192. Is that a perfect cube? No. Let's find the highest perfect cube we can divide those by, or that by.
Forty-four.
64 and
3.
Okay. The cube root of 64 is 4. Now we can look at our variables. 3 goes into 8 how many times?
2.
Twice. So that would be r to the r squared. How many would be left over? 1. Does 3 go into 2? No. So that's going to stay underneath the cube root. And 3 goes into 18 how many times? 6. So that would be t to the 6th power with nothing left over. So on the outside we have 4 r squared t to the 6th. On the inside we have the cube root of 3 rs squared. I could have wrote that separately and then we combined it. I just combined it. So everything that's underneath the cube root, the 3, the r, and the s squared, all would come inside. So 4r squared t to the 6th times the cube root of 3rs squared. With the last bit of time we have, I want you to try the remaining 6 problems. Not 6? Oh. Okay, we did more than, that's alright. So 15, 17, 19, and 21. Try those for And then we'll go over those here in a bit. I know most of you put this away, so just look and you can check your answers later. 15 was p squared times the cube root of p. 17 was 8y to the third times the cube root of xy. 19 was negative 2 times p to the fifth times q squared times the cube root of 4p to the second power times q to the second power. And then the very last one, negative 14 y to the third times z times the cube root of 6xz squared. The second Khan Academy on simplifying square roots with variables, you should be able to do that one now. Come see me today after school or tomorrow morning if you need help with either of the Khan Academies or the Delta Math, which is due next class. Or if you need to finish one of your tests or want to start a retest process.